Hey guys, Mr. Backerberg here. In this video, we're going to look at definite integrals as an accumulator function. So if we've got a function f that is integrable over the closed interval from a to b, then the definite integral of our function f from a to x defines some new function for x values that are between the a and b values within our interval, and that's the accumulator function, which we can call a of x, and that's the definite integral from a to that x value of our function f of t dt. So we're going to look at creating an accumulator function. So we're going to let our f of t function be 1 plus 2t for t values that are between 1 and 6. So we want to write out the accumulator function a of x as some polynomial in x, where this accumulator function is defined as the integral from 1 to x of this function 1 plus 2t dt for those t values between 1 and 6. So what we're going to look at doing is graphing out this 1 plus 2t. Now that's just going to be a linear function, a straight line. We're looking, I guess, specifically between the t values of 1 and 6. So I'm just going to mark some things out on my graph. So right here is the t value of 1, and if we count over, then this is our t value of 6. Now we're not necessarily looking at those end values, but what we're looking at doing is starting at this t value of 1 and then going over until we hit just some general x value in there. And the only restriction that we need is that x needs to be between these endpoints of 1 and 6. Now what we've just created in here is a trapezoid. So what we're going to end up doing is finding the area of our general trapezoid without necessarily knowing where this x value is. Now as far as the area of a trapezoid, it's 1/2 times the sum of the bases, so base 1 plus base 2, and that's all multiplied by the height of the trapezoid. Now as we're talking about the bases of our trapezoid, those are the sides that are parallel to each other. So in our picture over here, this side at 1, I'm going to call that my base 1, and this other side at our x value, I'm going to call that our base 2. And then our height is going to be this distance between that starting value of 1 until we hit that x value. So to calculate that distance, we're going to take whatever our x value is and subtract 1 from it. So now as we're looking at getting things filled into our area formula, we've got this 1/2 times. Now for this base 1, to figure out the length of that base, we need to figure out where we're hitting our function. So this is happening at a t value of 1. So then in our function, that 1 plus 2t, I'm going to plug 1 in there. Well, if I do 1 plus 2 times 1, then that's going to give me a value of 3. So that base 1 length is 3. But as we look at this other base, this might be a little bit more complicated. We've got this value of x, so we would be looking at trying to figure out the height of our function at that specific x value. Well, our function is 1 plus 2t, and we're plugging in x. So if I do that, if I do 1 plus 2 times this unknown x value that we're plugging in, then that just is the second base. So for this base 2, I'm just filling in that 1 plus 2x, since we don't necessarily know where that x value is. Now as far as the height of our trapezoid, we said this was laying on its side. So this x minus 1, this distance between the starting value of 1 and that ending value of x, that is the height of our trapezoid. So I'm going to fill that in on the back end here, x minus 1. Now the first thing I'm going to look at doing is simplifying down everything that we've got inside of the parentheses. I see that we've got some addition happening in here, and I can combine this 3 with this 1 right here. So we're going to have 1/2 times, well, 3 plus 1 is 4, plus this 2x, and then all of that is getting multiplied by x minus 1. Now if I take that 1/2 and distribute it into this set of parentheses, half of 4 is 2, half of 2x is just regular x, so we get 2 plus x, but then we still have to multiply that by x minus 1. Now that's going to take a little bit of foiling, so 2 times x is 2x, 2 times negative 1 is negative 2, x times x is x squared, and then x times -1 is negative x. Looking at doing some combining of like terms in there, and I'm also going to do a little rearranging, we're going to end up with x squared plus x minus 2 as our accumulator function. And then once we know what our x value is, wherever this x value is stopping along that axis, we can take that value and plug that into our accumulator function, and that'll calculate the area of this trapezoid underneath our curve and between the x-axis. So for example, if we stopped at an x value of 4, then I would just take that 4 and plug it into this accumulator function. So I would do 4 squared plus 4 minus 2. 4 squared would be 16, plus 4 more would be 20, minus 2, this would have an area of 18. That's going to be it for this video. Thanks for watching.